Okay. Excuse me. We're starting into the other book now. Chapter one is the Java building blocks, and I won't sit there and read that to you. But this talks about understanding the Java class structure, and fields and methods, comments, classes versus files. Talks about a main method here, how to write that. Gives you a criteria. I'm not gonna sit there and read all this to you, so I'll let you kind of read that yourself. And let's take a look at an example. I guess I could do the zoo example. Not a bad example. Um, okay, so I'm gonna come over here. I'm gonna do a file, new project, Java with Maven, Java application. Click next, and go ahead and click finish there. And down here, I'm gonna right click on this, and I'm gonna say new, and I'll say Java class. So we're going away from the GUI for a time being. And this class name they specifically called Zoo. Click finish. Now this is part I'll have to copy because I don't know it. Public static void main. I get bits and pieces, but string args. Okay, that looks like good enough. Okay, so that's our main class. Let me shut my door because we're cleaning or something. Partly shut it. Okay, well, this by itself is a class. This is an object. So we're creating a zoo. Um, we're going to use this as a driver program, but we could have a class actually called zoo. Now, if I come over here in my default package, although you could put it in other packages, which we'll see, I'll right click and I'll choose new and I'll choose Java class. What do we have at the zoo? Well, we have animals. So I can create a class called an animal. And I'll click finish here. You see you got a separate file here, animal. Um, and the book talks about difference between classes and files and so forth. I'm not going to really go into that. What can we have for an animal? Well, if I'm thinking about things to describe them, the type of the animal. So maybe a string, lowercase, string, um, animal type. Now, that's how we would define everything. And Alt Enter. Public. Maybe I do gotta put that there. Yes. Okay, there it goes. When we defined it before, we put the data type and then name. Hope that green doesn't mean that it's a reserved word. Here we have to put public, and we're going to see why here in a minute. Although we could change it to private, and it'd probably equally be just as valid. Well, besides animal type, might have a name. So public string name. Might have an age. So I say public int age. Now these We got fields and methods. Different programming languages called by different names. It says fields, more generally known as variables. I've seen in some programming languages they call class variables. Some call fields. Methods. That's usually called methods, but I suppose in different languages it might be called functions, procedures, subroutines. Well, I already said functions, but so these right here are class variables. In terms of the terminology we see over here, fields. Now, here we've created an animal.java. Let me close some of these. And then over here in my zoo, I want to create an animal. Maybe I got an elephant. So I'm going to say animal, elephant. Not elephant. Let's just call it A1. It's like declaring a variable, like int, and then num. Now we say A1 is equal to new animal, like this. What this is, this creates an instance of an animal. Well, think of it this way. You got games is the best way to think of this. My son used to love playing a Star Wars game. There's Pokemon game. My two stepsons before him loved Pokemon. I don't know how many Pokemon there is. Must be a gazillion of them. But in a particular Pokemon game, you have new Pokemon that'll appear. That's like a new instance of a Pokemon. They're all Pokemon, so they're all generalized as Pokemon, but all of them have different characteristics. Some of them have different names and so forth. Same with Star Wars characters. So this creates an instance of that animal. Now we want to assign the variables that we used over here, are class variables, animal type, name, and elephant. So back over here, this, after we create an instance, we can assign those. So we can do A1 dot animal type equals, and that'll be an elephant. We can do A1 dot name Sam. It's an elephant's name. And I don't know how long elephants live, but let's say this elephant's 30 years old. So I created an instance of it, and then I assigned these values. Now, what allows me to assign those values is the fact that I made these public. We're going to see private here in a minute and talk about the difference between those. Besides A1, I could have another animal in my zoo. I could have A2, I'll call it. So I'll say A2 is equal to new animal. Again, this creates an instance of the animal. A2.animal type. Something I can spell, gorilla. A2.name equals David. So the gorilla's name is David. And A2.age, the gorilla is 25 years old. So now I got two animals in my zoo, and I've created instances of them. Now, what this allows you to do, and game development is the best example of this, it allows you to create code that can be used across the board. So the same code I would create for an elephant, I could use for the gorilla. So it allows you to come up with reusable code. You try to think of things that are very specific to an animal, and that's what you'd put into your program. Well, if you think about a game, they come out with a new Call of Duty. It used to come out, I think, once a year. They came out with a new Call of Duty. Well, a year's time doesn't really seem like enough time to create a brand new game from scratch. It isn't. They don't create it from scratch. They reuse libraries. So they create objects where they define the movement of characters around in the game. And when a new Call of Duty game comes out, there are some exceptions to this, but a lot of them are just changed. The maps are changed. There's some other changes that occur too, but for the most part, they reuse a lot of that code. If you've created an object that you can reuse, so you got this code over here in a separate file you bring in, then you don't have to redo it from scratch. You can come out with a new map, new voices, kind of a glance over that's really the same game. Now, I know there's exceptions to what I just said. You might say, well, this when they went from this one to this one, they made quite a few changes, and yeah, sometimes they do. But a lot of times they reuse code for that reason. You can reuse code, like if you got a Call of Duty game and you got a Battlefield game and you got a Pokemon game. Some of that code you can spread across all three games. So again, that's the beauty of it. You're not going to see the true power of this, but if you do take a game development class, you'll encounter objects and you'll see how here at Cali anywhere where we use Unity, you'll see how Unity kind of uses the same building blocks across the board. So if you know how to change the position of one item, one game object, you know how to change the position of all the game objects because they're all using the same code, the same class. Okay, some of it's inheritance, which we'll talk about. Now that's set in the direct. Now this is poor design here, by the way. Typically, when you come up with an object, you don't make these public. That allows you to not have much control. Instead, what you do is you make these private. Okay, so by making them private, now if I come over here, if I try to run this, it give me an error. You see how these little red squigglies under here? By making it private, that means I cannot access them outside of this code right here. What's the benefit of that? Well, you cannot access the variables directly. You have to call a method to change it. Now I'm going to show this. Let me think. Public and void set animal type. And I'll be passing in a string. I'll call it S. And then I'll say animal type is equal to S. So if I want to set animal type, I now have to call this this set animal type here. If I want to return the animal type, then I'll have a public string get animal type. And this will just be a simple return animal type. Now, before I go on to the rest, for each class variable you have, what you'll find is that you'll have a get and set. And so then over here in my code, I no longer want to set that or set animal type equal to elephant in that manner. I'll say a1 dot set animal type. Oops, let's try it again. A1 dot set animal type elephant. Now this is accomplishing the same thing as this line of code right here. You might say, boy, it was a lot easier when you just did it public. Well, Well, yeah, but now I control everything. They're calling this method, which when they call it, comes over here and runs this, and I could have 200 lines of code here. So I could be going out to the database and I could be verifying that elephant is an animal that's contained or that is an animal. I could go out and verify the age. You know, if they put in 5,000, I could go out there and say, I don't think elephants can live that long. So I can do a lot within this method here. Okay. Well, again, we have to have the sets for all of them. They're all void because when you're setting, you're not returning anything. And so I'll set the name, and I'll be passing in a string again. I'll say name is equal to s. And then I'll do a public. I'm going to return it. So this is returning a string. So get name. The data type that's returned has to match the data type that it is. Name is a string, so that's why it has to match that. And then I'll just simply say return name. And last one, age. So I'm going to do a public void. Sets are always voids. Set age. And I'm passing in an integer here. And I'll say I. And I'll say age is equal to I. Now, age is an integer. So when I do the get, I do public int get age. Then I'm going to return age. So again, notice how these gets were a string and this is an integer. Now you might say, well, does it have to be a lowercase g, et, and so forth? No, I could say David was here, and it would work just fine. The standard is that you don't do that. That we know no matter what object-oriented language you go to, it's always gets. So get age, like that. So then over here, I'm going to do an a1.set age and 30. I guess I didn't do the name, did I? a1.set name Sam. I'm going to delete those. And down here, I want to do the set animal type. Gorilla. And here I'll do a2.set name. David. Just to give you a heads up where I'm headed with this, I'm going to have an assignment on this, and I want you to define your own object. Don't use animal. Don't use zoo. If you're into Pokemon, create Pokemon. If you're into whatever video game, create that. If you're not into a video game, then pick something that you can have instances of. You can have people. If you go into Walmart, before all this happened, any given time there might have been 200 people in Walmart. I'm just guessing, maybe 300. I don't know. They have those cameras, little globes up in the ceiling to see if you're shoplifting. There's no way it can follow 200 or 300 people. The perfect computer program would be one that has parallel processing, so it runs lots of different strands at a time. And each time somebody walked in the door, it'd create a new instance of a person. And it'd note down some things about you. Maybe it'd even take a picture of you and save that off in the database. And that then it would follow you all the way around. And That way, we'd have all 200 or 300 people watched instead of one person sitting back there bored watching the cameras, assuming there is anybody watching the cameras. Probably not. I've heard they got like people walking around, or used to have people walking around that were employees and look for shoplifters. So I guess if you look shifty, they would follow you around. And yeah, so that would be a perfect example of where this kind of multi-processing, parallel processing along with objects would be able to track people. Okay, now get. Um, let's see if I can remember this. System.out.print line. Let's say I want to print the gorilla's name or elephant's name. A1 dot, and then I have to do a get name. Now, what this is going to do is it'll call the get name over here, which does nothing except for returns a name. And when it returns a name, it returns that as a string, and it'll print it out. So now if I run this, and select zoo, same. That's interesting. Same. Set name. Sam. I'm sitting there. What is that? A keyword or same? What is that? Um, Sam. Okay. About ready to go home at that point. Been feeling tired, so I want to go ahead and get this recorded because I wasn't sure if I'd feel up to staying up tonight. I don't have any symptoms of the coronavirus going around or anything like that, but I'm just tired for some reason. So, let's see. Okay, so those are our gets and sets. Now there is another thing we can create here, and by the way, having a default animal class like this, it automatically has its own what's called as a constructor. Constructor is what creates an instance. So when you do this new animal here, it calls the default constructor. And you say, well, there's no constructor. I don't see anything. No, there isn't. It's kind of hidden. It's kind of invisible. You can create your own though. Let me show you a constructor. So if I do public animal, and identifier expected. Oh, there. Notice it has public because we're calling it, and this name has to match, but it does not have any data type involved with it. It doesn't have a class here. It just says public, and then this class name has to match this class name. So then I can default everything. So animal type, I can say is equal to unknown. So I can spell. Name is equal to unknown. And age is going to equal to 0. So over here, when I'm calling these, let's say I have a new animal, 83. Now say 83 is equal to new animal, like this. Now let's print out the name of the animal. So system.out.println a3.get name. And run that. So you see Sam, and then I have unknown. When I when I created this instance here, create another instance of an animal. It came over here and it said, hey, do I have any constructors? And it said, yeah, we have a constructor right here. So then it called this, and it went ahead and set these as my default values. So that's a constructor we have. Remember, we had that constructor that was invisible. It will no longer call that invisible constructor because we put a constructor in here. Well, let's say that I want to have another constructor, and in this one we'll pass in some parameters. I want to pass in the animal type. I'll say a type. I want to pass in a name, so animal name. And I'm going to pass in the age, so animal age. Now notice they're both public and they're both called animal. This one does not have any parameters. This one has 3 parameters. This is another constructor. Specifically, it's overloaded. Overloaded means you're using the name twice, but you got different parameters. So animal type is going to equal to a type. Name is going to equal to animal name. These are our parameters we're bringing in. And age is going to equal to age. So then over here, let's say I have a 4th animal, A4. Now, when I create that new instance, I can say equals new animal, and I can pass in what's my first animal type. What other animals are there? Hyenas. Hyena. And that hyena's name's Bill and is 2 years old. Now, if I do system.out.println a4.getName, see, it's prints Bill. So this combines a lot of code all in once. It creates a new instance of it and sets these 3 class variables to these values. Well, you might say, well, how does it know which one to run? You know, this called animal and this called animal. The constructor is called animal. Well, when it hits like this one here, it says, okay, I need to go see if there's a constructor called animal. So it comes over here, says, okay, here's my first one. Yeah, that looks good. No parameters, and this one has no parameters. So that'll run this one. When it comes down here, it says, oh, okay, here's another constructor. I need to go look for the constructor called animal. Comes over here, and it says, oh, okay, here's one. And then it says, whoa, wait a minute. This had 3 parameters, specifically string, integer. This doesn't require any parameters. Let's keep looking. So it comes down here. And it says, oh, okay, here's another one. Here's another constructor called animal, string, integer. String, integer. That matches. So that then runs this one. So based upon the type and how many parameters you have will determine which constructor it runs. I could have just one type, or one parameter, sorry, with our constructor. And I'll say animal type is equal to a type, name is equal to unknown, and age is equal to 0. Notice it is again named animal. Excuse me. So over here, if I were to create another animal, A5, let's say A5 is equal to new animal, and what other animals are there? There's wolves. Wolf. Then, since this only has one parameter, it's a string, it comes over here and it looks for a constructor that has one parameter that's a string, which is this one. So then it run this code. So that's overloading. And that's these are all constructors, um, and each of those is used to create an instance of an animal over here. Okay. Comments, you can read that. Let's see. Default initialization. So we got our local variables, class variables. A lot of this covers stuff we've already seen, local variables and so forth. So I'm trying to touch upon the new items here. See here where we have they may not get into objects too much here. Now I'm looking at this. Now to destroy objects. I'm not big on doing this, but it's not a bad idea because it returns memory. See, here is where we're creating an instance. They're doing it based upon a string, and then we got 1 is equal to 2, 1 is equal to null. So they're assigning one equal to another. So a lot of different things they're doing with it. And this shows you. Java allows objects to implement a method called finalize that might get called. This method gets called if the garbage collector tries to collect the object. If the garbage collector doesn't run, the method doesn't get called. If the garbage collector fails to collect the object and tries to run it again later, the method doesn't get called a second time. In this practice, it means you are highly unlikely to use it for real projects. Luckily, there isn't much to remember by finalize for the exam. Just keep in mind, and that'll talk about the finalizer on that. Let's see. I'll go to benefits. That's interesting. Maybe it's at the bottom of that page. It is. Key parts of why is Java so good? Well, it's object oriented. That's what I've just been showing you. So we're going to look at objects a lot more. This just kind of really covers a lot of what we've already seen. Encapsulation supports access modifiers to protect data from unintended access and modification. Most people consider encapsulation to be an object aspect of object-oriented languages. So again, that's an important piece. And then platform independent, which we've already talked about. In theory, you can run that on different platforms. It's robust, simple, and secure because it runs inside the JVM. Okay. This, where we're making these privates, is we're encapsulating this. We're hiding the details. I got a remote at home. Changes the channel on my TV. They didn't have to give me the remote. They could have gave me could have left the back of the TV open. Told me to go over with some electronic device and connect together this circuit with this circuit, so I would change channels or change the volume. They didn't want me to mess around with the back of the TV. They didn't want to have it open. So what they did is gave me a nice user interface. And they realized I'm not a very sharp individual, so they gave me one that has as few buttons as possible. You ever have a remote that has like 50 buttons on it and you can't figure out how to use this silly thing? I do got some of those at home. But my remote that Cox Cable gave me is a lot more simplified. Um, I wouldn't even know how to shift the screen over. I don't think there is any way to change the um, the brightness with the dummy remote that Cox gave me. They wanted me just to be able to turn it on, change channel, change the volume, maybe type numbers in if I want to go directly to a channel. All of that is strictly controlled on how I can interface with it. And that's the idea behind this encapsulation here. We're trying to make this as dummy proof as possible. So there's no way you can screw this up. I've got this defined, and if you're trying to create an instance of an animal, then it's exactly defined. Like if I come here and say I want to pass in a number here, it won't let me because it's controlled exactly how to call it. Okay, now that's all I really wanted to get into with chapter 1 for this. There's other nice interesting items there. I'll let you read that. When we get in some of these other ones, specifically chapter 4 and chapter 5, this is where you're going to see a lot of like methods and encapsulation, class design. You see those overload methods, passing data among methods, creating constructors, encapsulating data, writing simple lambdas. Get down to class design, and we'll talk about inheritance, because some things are inherited. I'm not very good with science, but I think animal kingdom, within the animal kingdom is the mammals, I'm guessing. Within the mammal category, genre, whatever the name is, there's humans, or maybe they're bipeds. Then human is a biped. I don't know. But that's where you have your inheritance. So a lot of different things we're going to be doing with objects in these remaining times. Again, what I want you to do is I want you to create your main driver program, like zoo.java or game.java or whatever you want to call it. And then you have another class where you'll define whatever. Could, like I say, be Pokemon, could be people. If you're trying to do it based upon an organization, this might be company, this might be department, it might be employee. We're going to see that actually works out pretty good when we're talking about inheritance, because an employee is a member of a department. A department is an organizational unit of a company. A company is a I don't know what it is. Building block of business. I don't know. Designing objects correctly. Games are easy, but designing objects within an organization is kind of a challenge sometimes. Sometimes you just do very simple objects in order to reuse them. One area that a guy I worked with used is we used to we used Oracle at my workplace, and we all wrote the interface to log into Oracle. Well, all of us are sitting there reinventing the wheel on each program, writing the same code to access the Oracle database. Well, he started thinking about it, and he thought, well, why are we doing this? Why don't I just create an object, and then when you call this object, you pass in the name and a password, and it does all the behind the scenes to log into the Oracle database. And so he created that object. And so from then on, we no longer had to write our 25, 30 lines of code to connect to that Oracle database. We simply had to call his object, passing in those parameters, and he controlled it all with these privates and so forth. So we couldn't screw it up. He made it dummy proof. And that's the beauty of objects, is you can reuse the code and you can make it so easy to utilize in various programs. Anyway, that'll be the assignment. Of course, within your driver program, I want you to create instances, and you don't have to do much exciting on it besides just try to have pick five class variables. I had 3. So pick 5 that goes along with whatever you're doing, set them equal to values, have different forms of the constructor. Have a constructor with nothing, have a constructor with all of them, have a constructor with a couple of them, just to get used to the concept. And over here, create instances of it. So if you're creating Pokemon, create a new instance called Pikachu. Whatever it might be. And then just do simple print lines, print the values you get with the gets. You should have, if you have 5 variables over here, you should have 5 gets and 5 sets that go along with them. Make them private. Do it right. Don't do it the public like I first showed. That's kind of the sloppy way. This is the correct way to do objects. I'll go ahead and stop there, and then I'll upload this recording.